Hello, good afternoon, everyone. My name is Jeffrey Gillan. I'm a data scientist and researcher at the University of Arizona. Thanks for coming to check out the talk. So I'm here to talk to you about how to make your drone imagery open and cloud native. With show of hands, how many people have or are collecting drone imagery in some way? We got 1, 2, all right. Okay, good. We've got some drone pilots. Okay, so before we get to drone, let me talk about the group that I work with primarily at U of A. So I work for a group or a project called CyVerse. And what are we? We are essentially non-commercial cloud infrastructure. What does that mean? We provide cloud compute and we provide cloud storage primarily for the research community. We started, I think, about 17 years ago, something like that. And it was all about plant genetics and genomics. And over this time frame, it's really expanded to kind of any kind of big data, astronomy, and my expertise is geospatial. So we host a lot of data. We want data. If you have data and would like it either free or low cost stored, we can help you with that. We are a node on the Open Storage Network, which is an NSF thing. So we have multi-petabytes of data storage. Open Storage Network kind of works like an S3 bucket, so a lot of good input-output. Yeah, you can move a lot of data if you like. And then we're also partners with Jetstream 2. Jetstream 2 is a research cloud computer funded by the NSF. It is housed at the University of Indiana. I am wearing Jetstream 2 socks, so I'm a big promoter of it. And if you have some compute needs, you can probably get yourself a free allocation to do some big, high-powered computing. There's a lot of GPUs if you want to use them, A100s, free to use if you are, it's primarily targeted for the research community, but if you're a nonprofit or even if you're a company, you can probably get an allocation. So please come see me if you're interested in such a thing. So CyVerse, we make an interface for Jetstream 2 that is what we call infrastructure as code. We use something called Ansible and Terraform to help people deploy and provision virtual machines with kind of a push button. And so, that's how we're involved in Jetstream 2. And at CyVerse, we are very interested and huge proponents of open science, open software, open data. We know the power of kind of the open source ecosystem and how much value it's given me and how much value it probably gives you. So we're always trying to promote it. We teach a variety of workshops on these topics. So we love open software and open data. Okay, back to drone. So I've spent the better part of 15 years flying drones over places like this, over southwestern forests. That's just outside of Tucson, where I live. Most of my background is flying drones over rangelands. Rangelands are like grazing lands or shrublands. We're talking arid, semi-arid places. I spent many years flying drones over them, and then also dry land riparian areas. So I'm still crazy about drones. I've been doing it since 2011. I started in Las Cruces, New Mexico, working for the USDA Agricultural Research Service, and I've been obsessed ever since. And so I'm here, got to talk about this first. If you are not a drone person, perhaps you've heard of them, or perhaps you know that they are useful for a variety of things. Here's the standard slide that I give of the value. People are using drones for agriculture. They're using it for construction, civil infrastructure, geology, mining. Back into my area of expertise, wildfire monitoring, forestry applications, ecosystem monitoring, and disaster management. So drones provide this really great eye in the sky, right, at a scale and an on-demand thing that can't be achieved by satellite or by boots on the ground. So it provides this great kind of middle scale that's just really useful information. So I'm trying to make anyone that's collecting drone imagery, how do we make tools to facilitate it to make it more open and more usable to the world? So I am here to ask you, please, share your drone imagery. Why? One, you can give your data a second life. I probably don't have to explain to this crowd the value of open data, open science, open collaboration. So make your data available to the world. Drone imagery is unique is that it's being collected by tens of thousands of people around the world in kind of small batches. And in and of itself, it might not be powerful, but if we can pool them, they can be quite an amazing data set. We can pool them for machine learning models, which a lot of people are doing. And of course, drones can be very useful for training and validation of these larger scale satellite products. So think of like carbon mapping or wildfire fuel mapping, stuff like that. So those are the kind of the applications I'm interested. All right, so imagery sharing platforms. So I got to make a shout out to Open Aerial Map. They were kind of the first people that really did this, that we can make a website, people can upload drone imagery in kind of a crowdsourcing way, and it can have value. And over the last 5-6 years, there's been a proliferation of a lot more platforms that are doing similar things. So let me just show you some of the ones that I like. I found as many logos as I can. Got Open Aerial Map on there. GeoNator is a company out of Australia. It's a for-profit company, but they any kind of raw data you give them, they make it fair, free, accessible, interoperable, and reusable. Of course, you can put drone imagery into Earth Engine, which makes it really powerful for analysis. Friends over at Open Topography accept drone imagery in a lot of ways. There's a web platform called DroneDB, which is great for organizing. And my new favorite one is deadtrees.earth, which is like this fantastic kind of case study where it's a crowdsourcing effort, upload your drone imagery. When you do so, they automatically run a machine learning algorithm to identify all the dead trees in your imagery. And they give you that like annotated layer just like in like 15 minutes, just all automatic. So it's a really cool platform, and I try to strive to be like them. So yeah, deadtrees.earth, check it out. There's repos just collecting aerial wildlife data. Imagery Data Manager, I believe, has been made for the Department of Interior. So there's a lot of different options. If you're looking for drone data or you want to share your own, find one of these and make it available to people. Here's a list of just other places where I know people have and are putting drone data. Things like Figshare and Zenodo. These are just general data repositories. I don't think they're a great place to put drone imagery. I prefer you put them in places that are more dedicated to drone, but still this works. You can go to Zenodo and probably find drone imagery. So yeah, we have some options, so choose one. And so the remainder of my time, I want to talk about a couple different efforts that I've been involved in where we're trying to make drone imagery more accessible, easier to find, and tools around it. So the first one is called Open Forest Observatory. You can find us at openforessobservatory.org. It's based at UC Davis, so we are federally funded, or at least have been. See what happens. And UC Davis partners with CyVerse at the University of Arizona to host all the data. And so what Open Forest Observatory is it's a database of forest plots, primarily on the West Coast right now. And so at a forestry plot, we've got a suite of drone data and ground data paired. And so it's like ground truth of this is the exact tree species. And I think they also do forest mensuration stuff like diameter, breast height, and kind of more of those classic forestry measurements. And everything is paired with a suite of drone products. Here's a typical thing that we create is detected trees. So we make orthomosaics and point clouds, and then try to identify all the trees, how tall are they, and then we're also working on tree species and making that available for all our forest plots. So besides a database, Open Forest Observatory is really into making tools regarding processing and analysis of data. A lot of it's around photogrammetry. So we have a virtual machine template that you can launch in Cacao, and so you could launch this directly in Jetstream 2 or in AWS. So Terraform and Ansible is kind of an agnostic language, and you can launch it on different clouds. And so what we've built is like a push-button virtual machine that will launch different size flavors if you want, with GPUs, without them, that's loaded with aerial imagery analysis software. So that's one thing we've created. Anyone can use it for free. We've also built photogrammetry pipelines. We're really into Docker pipelines, Docker Compose, putting that in with Python, and we do it for photogrammetry programs like Metashape or OpenDroneMap. And so that stuff is all on GitHub and easy to find and easy to use. We have an R package. The R package is all about kind of tree identification, stuff like that. We have a Python package called geographer, and so this is targeted to machine learning for forestry. And if you're familiar with drones at all, typically if people are trying to do classification or machine learning stuff on drone stuff, it's usually on a single orthomosaic, top-down nadir orthomosaic. But if you've ever done drone, you realize that we've just thrown away 90% of the data, because typically in photogrammetry, you're collecting hundreds, if not thousands, of images, and you're getting all kinds of views of trees, from all kinds of different sides, left, right, above. And so geographer is a Python library to help you connect inference on raw drone images and project them into your photogrammetry products. So it's just trying to make machine learning a little bit more robust and better for drone stuff. And of course, we are serving out all of the data in a Stack API. We're making everything available as a cloud-optimized GeoTIFF and also cloud-optimized point clouds. So thanks, guys, who invented Stack and Copic and Cog. Those are great inventions. Okay, so that's one project, Open Forest Observatory. And the other one I want to mention is something called Data to Science. So I am not involved in the development of this, really. I consider myself more of a platform evangelist. And so Data to Science is something similar to like Open Aerial Map, but it's a bit more updated. It's been developed just recently. You can find an online version that you can play with right now at this website, ps2.d2s.org. And so what is it? It's an open source web platform for storing, visualizing, and sharing drone data. The whole website is containerized. It's on GitHub, so you can easily serve your own if you like. And so it's developed by Jinha Jung and Ben Hancock at Purdue University. They've done a fantastic job of making this stuff. They took kind of the concept of Open Aerial Map, but just kind of updated it a little bit more. And so when you upload imagery into it, it automatically becomes a cog, or it automatically becomes a cloud-optimized point cloud, and it's really easy to share things out. So I just want to give a quick little demo of it. Okay, so it looks like a typical mapping interface here. You get an account, you can upload drone imagery products from orthomosaics to DEMs to classifications to point clouds. And then that data gets put on a map. Let's see, which one should I go to? So we're zooming into Tucson, and this is all my drone stuff that I put in. Okay, I collected drone imagery along the Santa Cruz River a few years ago, and you can visualize, this is a classification of different vegetation species. And what I love about Data to Science, or D2S, we call it, is its sharing capabilities. And so I can just hit share, and I can give anyone the URL for download, or I can I can give them like a shared map, or anyone can just look at it without a user account. Let's try this. Show QR code. So somebody hit that QR code with your phone, and let's see if it works. Live demo. Oh my God, we're about to overwhelm the server. What do we got? What do you see? Do you see the classified map of Santa Cruz River? Yay, okay. Yay. Okay, so in the background, it's using cogs. It's using T-tiler as the dynamic tile system. What else? Different than other drone platforms, we can do things in 3D, and so you can upload point clouds, and we can have a nice visual of them. So this is outside of Jemez, New Mexico, and this was for a wildfire fuel project we did. We're trying to tell the landowners, like, how fire-wise were they around their houses? Not very fire-wise. People love trees, it turns out, around their houses, and that's kind of dangerous for wildfires. Anyway, so you can upload and then share out these point clouds. Anyone with the internet can just look at these point clouds in their browser. So like the sharing capability is what I love about data to science. The thing that I've been using data to science for a lot is the fact that it has a Python library associated with it. So data to science is like the beginning of my machine learning pipeline. I put images into it, and then I can pull out my Python library and bring any image directly into a Jupyter notebook or whatever Python environment you might be using. And so it's kind of the start of my ML pipeline. That's where I keep all my data. So we have a Python library and also a QGIS plugin. And so we're really trying to facilitate kind of this open source ecosystem. Yeah, with the QGIS plugin, you can just bring any data that you had in D2S and bring it right into QGIS for whatever analysis you would like. And that's all I got. Thank you very much. My name is Jeffrey Gillan. Please hit me up on email if you want to talk about drones or want to talk about how you can get a free allocation to do machine learning with GPUs on Jetstream 2 or anything else. So thank you guys very much. Any questions?
Is this on?
Is that working?
Might not be on. Well, I can talk loudly. So there's a lot of different types of drones,
Yeah.
a lot of different sensors on them.
Yeah.
And so this dream of combining all these data from all these drones is very exciting, but there's probably a whole lot of details that need to be worked out to how to do that. I guess, like, how do you approach that problem?
Yeah, that's the thing. When people talk drone, they're like, it is unwieldy. There's a lot of different data types. Everything that I've showed you is primarily interested in RGB. I guess we're trying to prove the concept of what we're doing, trying to keep it simple, and we've not really gone into multispectral or hyperspectral. And yes, things are going to get more complex. And I think drones are always going to be kind of messy, and I think about that when it comes to metadata also. If we can all connect everyone's drone data via stack, which is great, are we ever going to agree on like what we say in the stack? Yeah, I feel like it's always going to be much more messy than satellites or airplanes, where the creators are very few and everyone can kind of agree on standards. Drone I feel like it's always going to be kind of this wild, messy thing, but like CNG, I think slowly little standards will come together. We'll figure out what goes into the stack catalog, but I'm not thinking too much about it because it kind of freaks me out to think about multispectral and hyperspectral and all the complexities with different drone types, or if you're using LiDAR So for the most part, we're keeping it simple right now with red, green, blue, simple sharing.
Thank you, Jeff, for the interesting presentation. My question is, you guys support APIs so we could connect to the massive collection of the drone data?
Is that a question? Do we support APIs?
Yeah.
In data to science or in Open Forest Observatory or in general?
Or both, yeah.
Yeah, okay. So we're big into Stack. We serve out our own Stack API at CyVerse that has all the Open Forest Observatory data into it. With data to science, they're doing that through a Python library. And so everything they have, I believe, is in a Postgres SQL database, and you're accessing it all through Python. So yes, I believe APIs or a way to kind of grease everything and make things quicker programmatically. And we're absolutely wanting to continue to support that.
Thank you.
Welcome. Hello.
Hey, I just had a question about the VM template that you created, the Cacao.
Okay, Cacao.
Yeah. Is it designed to only work in one large system, or have you designed it in such a way that, like, you mentioned that it worked on Jetstream 2, but it could also work on AWS? Could it work on distributed systems or cloud storage, or is it more designed to be like one large EC2 instance?
Probably
where it
one
just downloads
large.
everything?
Yeah, probably one large, like onto Jetstream 2 or AWS or Google Cloud. I think one at a time. Doing what you asked, distributed or whatnot, is probably beyond my expertise. I am not necessarily a cloud native developer. We have a team of people that are much more versed at Terraform, Ansible, and deploying virtual machines than I am. But my understanding and what I use it for is specifically for like one cloud or another.
Cool. All right. That was my only question.
Thank you.
Thank you. I used to work for the Forest Service in the drone program.
Excellent.
Over 300 pilots, and we used IDM as well.
Okay, I would love to see a working example of it.
Yeah.
Yeah,
Yeah.
if you could point me in the right direction. I know it's open source and on GitHub, but I've never seen like an actual implementation. I'd love to just like compare.
Sure. Yeah, absolutely. It looks very familiar.
I bet.
But kind of getting at that first question, not all drone imagery is equal, and not all collections are equal.
Yeah.
And one question we've had is, well, this data was bad. Do we take the money and time to host it? And I wonder if you had any thoughts on kind of QA/QC before you post the imagery and host it on these platforms.
I don't think I have a good answer for you, honestly. I've been more focused on can we do it and not getting hung up on the QA/QC, which is super important. I don't think that's really the realm that I'm going to be able to contribute very well to, but yeah, no, that is the big thing that people talk about with drone. It is unwieldy. It can be collected in 1,000 different ways. How good is the photogrammetry? Is there accuracy assessment associated with it? How
Right.
precise is this? How precise is that? Yeah, no, that's a real challenge. And right now, I guess we're going off the fact of if you can volunteer as much information as you have, great. And then the user of it, caution. If you're using it, then maybe you need to directly contact the person who provided it, or user beware kind of thing.
Yeah, and like the Wild West, like you said. So thank you.
You're welcome. I have glossy color brochures at the back of the room for Jetstream 2. So the NSF, I know, wants people to use their cloud computing system. You can get a free allocation, so please check us out, Jetstream 2. Bear down.